In section 6.1, we're looking at algebraic expressions and formulas. Let's see what the distance between you and your TV has to do with algebra. The biggest difference between arithmetic and algebra is the use of variables in algebra. A variable is a letter that represents a variety of different numbers. For example, we can let x represent the diagonal length in inches of a high-definition television. The industry rule for most of the current HD TVs on the market is to multiply the diagonal length by 2.5 to get the distance in inches at which a person with perfect vision can see a smooth image. This can be written as 2.5 times x, but is usually expressed as 2.5x. An algebraic expression is a combination of variables and numbers using the operations of addition, subtraction, multiplication, or division, as well as powers or roots. Examples of algebraic expressions could include x plus 2.5, x minus 2.5, 2.5x. This should read as x divided by 2.5, 3x plus 5, or square root of x plus 7. So as you can see, they look very different from each other. Now, evaluating an algebraic expression means finding the value of the expression for a given value of the variable. For example, we can evaluate 2.5x for x equals 50. We substitute 50 for x, and we obtain 2.5 times 50, which is 125. This means that if the diagonal length of your TV is 50 inches, your distance from the screen should be 125 inches, or approximately 10.4 feet. Many algebraic expressions contain more than one operation. Evaluating an algebraic expression correctly involves applying the order of operations agreement that we studied in a previous chapter. So just as a reminder, the order of operations agreement says we perform operations within the innermost parentheses and work outward. This can include any sort of grouping symbol, whether it's square brackets or curly braces. If the algebraic expression involves a fraction, you treat the numerator and the denominator as if they were enclosed in parentheses. You will evaluate all exponential expressions, perform multiplications and divisions as they occur from left to right, and then same thing for addition and subtraction, you work them from left to right. So let's go ahead and put this to the test. Number 1, we're going to evaluate 7 plus 5 times x minus 4 cubed for x equals 6. So wherever we see x, we are going to plug in a 6. So when I write this with our variable replacement, we have 7 plus 5 times 6 minus 4 cubed. And so by order of operations, the first thing that I want to simplify is inside the parentheses, which is the 6 minus 4. So we have 7 plus 5 times 2 cubed. The next thing on our list is exponential expressions, so that means the 2 cubed is going to be simplified next. So we have 7 plus 5, and 2 cubed is 8. Now that we've done that, we want to look at our multiplication. So 5 times 8 is next on the list. And 5 times 8 is 40. And 7 plus 40 is 47, which is my final answer. Let's go ahead and try this with example number 2. We have x squared plus 5x minus 3, and x is negative 6. So when I plug in negative 6 for x, I have negative 6 squared plus 5 times negative 6 minus 3. The parentheses in this case are just indicating multiplication. When they talk about parentheses, it's when it has 2 or more terms inside of that grouping symbol. Here, we're just using it to group the negative and the 6 together. So what we want to do, because we don't have any grouping symbols to simplify, is we're going to look at our exponential expressions, which is the negative 6 squared. Now when I square a negative 6, this is going to become a positive 36. And then the rest is going to stay the same. The next thing I want to simplify is my multiplication, which is 5 and negative 6. And so 5 times negative 6 is negative 30. Then we want to approach our addition and subtraction from left to right. So looking at 36 minus 30 first, this gives me 6 minus 3, and 6 minus 3 is just 3. For example number 3, we have negative 2x squared plus 5xy minus y cubed. X is 4 and y is negative 2. So it works the same way even though we have two variables to replace. So wherever I see x, I'm going to put 4, and wherever I see y, I'm going to put negative 2. So we have negative 2 times 4 squared plus 5 times 4 times negative 2 minus negative 2 cubed. And so again, the parentheses here are just indicating multiplication, and so we need to simplify our exponential expressions first, and this time we have 2 of them. 4 squared is 16. And negative 2 cubed is negative 8. What I want to do now is I'm going to look at multiplication and division from left to right. So the first multiplication is negative 2 times 16, which is negative 32. And then we have the next set of multiplication, which is 5 times 4 times negative 2. And 5 times 4 is 20, and 20 times negative 2 is negative 40. And then we have this double negative that we want to make sure that we take care of. So we want to change this to a plus 8 at the end. So negative 32 minus 40 plus 8. And we want to then approach this from left to right. Negative 32 minus 40 is going to be negative 72 plus 8. And negative 72 plus 8 is going to give me negative 64. An equation is formed when an equal sign is placed between two algebraic expressions. One aim of algebra is to provide a compact symbolic description of the world. These descriptions involve the use of formulas. A formula is an equation that uses letters to express a relationship between two or more variables. The process of finding formulas to describe real-world phenomena is called mathematical modeling. Such formulas, together with the meaning assigned to the variables, are called mathematical models. So for example number 4, the bar graph shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. The mathematical model W equals negative 66x squared plus 526x plus 1030 describes the number of calories needed per day by women in age group X with moderately active lifestyles. According to the model, how many calories per day are needed by women between the ages of 19 and 30 inclusive with this lifestyle? So we have the model, but we need to know what X is. So in our description here, it told us that X is the age group. And so we're looking at the 19 to 30 range on our graph. And so they fall under group 4. And so that is what X is going to be. I don't need to know anything else from this graph except for the fact that the women between 19 and 30 ended up in group 4. And so X is equal to 4. So just like in the previous examples, I'm going to plug in X equals 4 into our model. So we have negative 66 times 4 squared plus 526 times 4 plus 1030. I don't have any parentheses to simplify, so the first thing that I want to do is I'm going to simplify my exponents. So negative 66 times 16 plus 526 times 4 plus 1030. Then I want to simplify my first multiplication, which is negative 66 times 16, and that gives me negative 1056. I want to simplify my next multiplication, which is 526 times 4. So we have negative 1056 plus 2104 plus the 1030. Let's go ahead and simplify the first two terms. This gives me 1048 plus 1030, and that ends up giving me a total of 2078, and this is the calories needed per day. So a woman from 19 to 30 who have a moderately active lifestyle need to have 2078 calories per day. We have seen that an algebraic expression combines numbers and variables. Here is another example of an algebraic expression. 7x minus 9y minus 3. The terms of an algebraic expression are those parts of an algebraic expression separated by addition. For example, we can rewrite 7x minus 9y minus 3 as 7x plus negative 9y plus negative 3. And so everything in between our plus symbols is our terms. So 7x, negative 9y, and negative 3. The numerical part of a term is called its coefficient. In the term 7x, the 7 is the coefficient. In the term negative 9y, negative 9 is the coefficient. Coefficients of 1 and negative 1 are not written. Thus, the coefficient of x, meaning 1x, is 1. Similarly, the coefficient of negative y, meaning negative 1y, is negative 1. A term that consists of just a number is called a numerical term or a constant. The numerical term of 7x minus 9y minus 3 is negative 3. The parts of each terms that are multiplied are called the factors of the term. The factors of the term 7x are 7 and x. Like terms are terms that have the exact same variable factors. For example, 3x and 7x are like terms. So to simplify algebraic expressions, we're going to use some properties of real numbers. The commutative property of addition says that I can add anything in any order. So a plus b is the same thing as b plus a. The commutative property of multiplication is the same idea, but with multiplication. So a times b is the same as b times a. The associative property of addition just says that I can move the grouping around and still get the same answer. And the same idea goes for the associative property of multiplication. The distributive property just means that I distribute the term to each piece inside of the parentheses that follow. So the distributive property in the form BA plus CA equals B plus C times A enables us to add or subtract like terms. For example, 3x plus 7x, we can take the x out of both terms and add the coefficients, and we get 10x. Same thing for 7y squared minus y squared. That's the same as just doing the 7 minus the 1, and we get 6y squared. So just be very careful that the variable does not change, only the numbers in front change. And this is called combining like terms. An algebraic expression is simplified when parentheses have been removed and like terms have been combined. So let's go ahead and try example number 5. 5 times 3x minus 7 minus 6x. Well, the first thing I want to do is drop the parentheses, and to do that we're going to distribute the 5 to both pieces. So we have 5 times 3x, and we have 5 times negative 7. And we still have our minus 6x, and we just kind of bring that along with us. So according to order of operations, we need to simplify our multiplication first. So 5 times 3x is going to give me 15x, and 5 times negative 7 is negative 35, minus 6x, and my like terms here are the 15x and the negative 6x. And so 15 minus 6 is 9, and then we keep the same variable, so x, and then we still have our minus 35. So my final answer is 9x minus 35. And that is as simplified as that gets. Let's try something a little bit more complicated. We want to simplify 6 times 2x squared plus 4x plus 10 times 4x squared plus 3x. So we need to distribute both of these so we can drop the parentheses. So we're going to distribute the 6 to both pieces, and we're going to distribute the 10 to both pieces. So we have 6 times 2x squared, and we have 6 times 4x, and then we have 10 times 4x squared, and we have 10 times 3x. And so let's go ahead and simplify the multiplication first so we can combine like terms. 6 times 2x is going to give me 12x squared. 6 times 4x is 24x. 10 times 4x squared gives me 40x squared. And 10 times 3x is 30x. So remember that the variables have to look exactly the same. So I can't combine x and x squared together. I can only combine x squareds with x squareds and x's with x's. So in this case, 12x squared and 40x squared can be combined together, and 24x and 30x can be combined together. So 12 plus 40 gives me 52. And we have the same variable, which is x squared. And 24 plus 30 gives me 54. And again, we still have the same variable, which is x. So my final answer is 52x squared plus 54x. It is not uncommon to see algebraic expressions with parentheses preceded by a negative sign or subtraction. An expression of the form negative times a plus b can be simplified as follows. Remember that this is just a negative 1, and so when I distribute the negative 1 to both pieces, what ends up happening is that the signs of the terms inside the parentheses change. They were both positive to begin with, and when I'm done, they both became negative. So if a negative sign or a subtraction symbol appears outside parentheses, you drop the parentheses and change the sign of every term within the parentheses. For example, the negative outside 3x squared minus 7x minus 4. Because 3x squared was positive, it turns into a negative 3x squared. Because 7x was negative to begin with, it turns into a positive 7x. And the same thing goes for the negative 4, it turns into a positive 4. So for the last example, we're going to combine all of these things together. We have 8x plus 2 times 5 minus x minus 3. So we have a lot of grouping symbols going on here. The first thing we want to do is look at the innermost grouping symbol, which is the x minus 3. So let me just go ahead and rewrite this. And so what we want to do first is we are going to drop the parentheses and change the symbols inside. So we have 8x plus 2 times 5. We're going to end up with minus x and plus 3. The parentheses are gone, and the only thing we have now is the square brackets. The square brackets are still grouping symbols. So we can simplify the inside first by combining like terms. We have a 5 and a 3. So we have 8x plus 2 times negative x plus 8. So think of these brackets as parentheses. What we can do now is we can distribute the 2 so that we can get rid of the grouping symbols and we can combine like terms. We have 8x, and then when we distribute, we have 2 times negative x, and we have 2 times 8. And so let's go ahead and simplify this. We have 8x, 2 times negative x is negative 2x, and 2 times 8 is 16. So now that we're here, we just want to combine the last like terms, which is 8x and negative 2x. And remember, only the numbers change, not the variable. So 8 minus 2 gives me 6. We still have x, and then plus 16. So my final answer is 6x plus 16.